Okay, this will be a video on how to do the double replacement reactions lab. In lab, we would be mixing aqueous solutions to see if a reaction occurs. What this means is we would take solutions containing salts or acids or bases, mixing them together and seeing if a reaction occurs. One of two things need to happen in order for us to say a reaction occurs. One is if a solid is formed. The other is if a weak electrolyte or a non-electrolyte is formed. We'll talk more about that in a minute. But basically, a weak electrolyte is a weak acid. A non-electrolyte, in our case, is just going to be water. So, we're doing this lab as a dry lab because it's possible to predict whether a reaction will occur or not. It's complicated to do this, but each step is fairly easy. You just need to pay attention to what you're doing and follow some steps. Okay, so your assignment for this lab is to complete the pre-lab assignment and the post-lab worksheet assignment. Both of them involve using these following steps. The first one is to predict the products. Then you need to balance the equation. Then you need to check the solubility of each product because the reactants are all soluble. We're mixing soluble solutions together, so we know that the reactants are all soluble. If none of the products are insoluble, then you're going to check to see if one of them is a weak acid or water. If all the products are soluble and none of them are weak acids or water, then the reaction does not occur. There is no net change. You can write NR for no reaction. If one of the products is insoluble, or if one of them is a weak acid or water, then you need to write the total ionic equation and remove the spectator ions to form the net ionic equation. Okay, so I will do the first 4 reactions in the post-lab assignment. So let's go up there. Where is it? Okay, so here we are. Here's the post-lab assignment, and hopefully you can see this. What you're supposed to do is complete and balance the following equations in the molecular form, total ionic, and net ionic formats. Okay, we're going to use aqueous for AQ for aqueous solutions, G for gases, L for liquids, and S for solids. We're going to use the solubility rules on the separate sheet of paper that you were downloaded to see what the states are of the product, okay? And then it says, if you expect no reaction to occur, write NR in place of products. So the first one is the reaction between sodium chloride and potassium nitrate, and they give you the formulas. So the molecular format is just the equation that the way you've been seeing it. So in this case, it's NaCl, and we know it's aqueous because we're all starting with aqueous solutions, plus potassium nitrate, KNO3, goes to form. Now you have to predict the products, and I've already done it here, but basically it helps if you put the total ionic format, if you start writing it out, because when you put sodium chloride in water and it dissolves, it's no longer sodium chloride molecules floating around, it's sodium ions and chloride ions. Likewise, potassium nitrate, when you put it in water and it dissolves, you have potassium ions and nitrate ions. So this sodium will form a compound with this nitrate, and that's sodium nitrate. I didn't put the state because we're going to look that up. The other compound that could be formed is potassium with chloride, and they're both got a +1 or a -1 charge, so it's just 1 to 1 for these guys. So we don't have to do any balancing because it's all 1 to 1 to 1 to 1. But let's look up the solubility. All right, solubility rules. It says compounds with ammonium or alkali metal group 1 cations are soluble. Well, both sodium and potassium are in group 1. So the compounds, any compound that has sodium in it or potassium in it is going to be soluble. So we can stop there and move to the back to where we were. So we know that this is aqueous, AQ, and that this is aqueous, AQ. All right, so we can finish filling out our total ionic formula. We have Na plus whoops, that didn't work so great, did it? Hold on one second. Plus NO, NO3, whoops, dang it. Plus potassium plus Cl minus. Okay, so when we go to write our net ionic equation, we're going to cross out anything from up here that is the same on both sides. So let's take a look at that. Well, over on this side we have sodium, and this side we have sodium, so we can cross those out. Over here we have chloride ions swimming around, and here we have chloride ions swimming around. Cross those guys out. We have potassium ions swimming around, and potassium ions swimming around. Yep, they get crossed out. And then finally we have nitrate ions over here and nitrate ions over here. Guess what? There is no net reaction. So what we're going to do here is write an, oh come on, NR. So that's all we have to do. All right, let's look at the next one. The next one is the mixture of sodium chloride with silver nitrate. And I've written it down here, NaCl plus silver nitrate. And I've written the first part of the total ionic formula. We have sodium ions and chloride ions and silver ions and nitrate ions. Well, this sodium is going to react with this nitrate to form sodium nitrate. Silver is going to react with this chloride to form silver chloride. Once again, it's all +1 and -1, so it's 1 to 1 to 1 to 1. So let's look at our solubility and see what that looks like. Okay. All right, so for sodium nitrate, we know it's going to be soluble because it fits rule number 1. Compounds with ammonium or alkali metal group 1 cations are soluble. So we can say that this is AQ. All right, so now we have to just figure out our silver chloride. Okay, so silver is not a group 1 metal. It's not a compound with nitrate, chlorate, perchlorate, or acetate. Okay, here we go. Number 3, it says compounds with chloride, bromide, or iodide anions are soluble, except those with silver. Okay, so that means that our silver chloride forms a solid. It's no longer swimming around in solution. It is a solid, and so we put an S there. Okay, so now we can finish our total ionic, and we have Na plus, still, because this is soluble, and nitrate, NO sub 3 plus minus. All right, and now instead of having silver ions and chloride ions swimming around in solution, we have silver chloride solid. Okay, so now let's look at our net ionic again. All right, so on this side of the equation we have sodium, and over here we have sodium. I shouldn't cross them out until I say that. Well, chloride ions are swimming around over here, but now chloride is bound up in this solid, so we can't cross those out. Same thing with silver. We can't cross those out either. Nitrate, however, is swimming around in solution over here and still swimming around in solution over here, so I'm going to cross those out. So our net ionic equation, written down here, and I got to stop that. So okay, is going to be Cl minus plus Ag plus. No, I don't want to do that. Okay. All right, ignore the little dots because I'm obviously not very talented at this. All right, goes to form silver chloride solid. Okay, so that would be our net ionic formula. Okay, I'm going to have to stop this here and continue with another video.